All right, so here we are with question number 1, which is very similar to the questions we did yesterday. In this question, it says that there is a balloon that starts off being filled with 180 cubic inches of air, and then it's blown up into a bigger balloon that's now filled with 294 cubes of air. So the volume's changed. In this question, they want to know how much has the radius changed from where it was to what it is now. So the balloon's definitely got pumped up with air. The question is, how much has the radius changed? So we're going to have to find the radius here and also find the radius here. And this looks just like the ones we did in class, except it's two balloons in the same question. Well, it's a balloon, and what shape is a balloon of all the shapes that we've bumped into? A sphere, a full sphere. So you're going to use the volume formula for a sphere. Volume equals 4/3 pi r cubed. And then put in what you know. So we got some rhythm going on these yesterday. Put in what you know. You know the volume. You know the 4/3 goes there. You know the pi goes here. The only thing you don't know is what r's worth. So I thought I did enough of them with you yesterday so you caught on with what to do. Once I finish writing that, what should be the next step? Do some division. And if you can divide it all in just one big gigantic step. So we're going to divide both sides by 4/3 pi. If you use this trick to do it in just one step, what do you have to remember to do? Put parentheses around the denominator. On the right-hand side, the 4/3 disappear, the pi's disappear, and the only thing left is r to the third. On the left-hand side, when you divide these, you get about 42.97. So that work gets us really, really close to the final answer. Now it's going back to using the calculator and how to get rid of that 3. So what do you remember from yesterday about getting rid of the third power from these questions? Yes, so Mackenzie remembers properly. You got to use the cube root to get rid of it. And to get that on your calculator, on the graphing calculators, you have to press the math button and look for the cube root symbol, which is the 4th one on the list. So you type in the cube root of 42.97, and you find out that the radius for the balloon at the very beginning was 3.5 inches. And then I'm not going to go through the bigger balloon. It's exactly the same moves with just different numbers. And you end up getting that the bigger balloon has 4 1/8 or 4.25 inches for its radius. So instead of showing you the same show again, to speed it up, that's the answer for the bigger balloon. And then at the end, they want to know what the difference is between the two balloons. How much did the radius increase by? So it ended up with 4.125. It began with 3.5. If you subtract them from each other, you get about 0.6 inches difference. Okay. So on this question right here, question number 2, they're telling you the volume in gallons, and that's something to notice and to be aware of, that they're giving you the volume in gallons. If you look down below, at the end, they're giving you a conversion. So there's a 100% chance that you're going to have to convert gallons into cubic feet. So how many cubes of gas is 20,000 gallons? What would you do with this number? Even before we go on to to the rest of the question. What would you do with that number and the 20,000? Would you multiply them together? Would you divide them? Would you add them? Would you subtract them? What makes the most sense? Dividing makes the most sense, but why? And you want to get rid of the gallons. So you want the gallons to disappear. So you want the gallons to be underneath so that they'll cross out. So when you do that, you end up finding out that the volume is actually 2,673.797 cubic feet. So that question had a start to it that was different than things that we did yesterday, because I didn't give you that start. Okay, once you finish that conversion, it makes the question a lot easier, but you still have to understand what they're after. They want to know how long this pole is that sticks inside the tank. And they gave you some information. They said that 1 foot of it has to be sticking out of the tank so they can grab it. And how about this part that's in the tank? What would that yellow line be called in the tank? Is it the height of the, would it be the height of the tank, or would it be the diameter of the tank? Well, you might think height, but since it's a cylinder, the cylinder is considered to be having two bases that are the circles. And if you stood it up on its end, the bases would be circles, so the height would be this measurement here, and this yellow line would be the diameter. So if we could find the diameter, we just have to add 1 to it to come up with how long the stick is. And to find the diameter, we'll have to find the radius first, using what we did yesterday. So now that we've got all these facts here, we can actually use the volume formula. So the volume is pi r squared h for a cylinder. And you never know what you're going to get points for on the test. Like, if you converted and wrote down the cylinder formula, you're probably already getting 1 out of 4 points no matter what. If you missed the conversion, which I know that a few students have, if you use the 20,000 instead of converting it, I mean, the worst you could get was 1 point taken off. So there's a lot of credit you can get here. So the volume we found out was 2673.797. And we got pi. The radius we don't know. And the height of the tank, well, they told us it was 34.5 feet all the way across. So that would go there, 34.5. Okay, and then you're one small step away from getting r squared alone. We did that a ton yesterday. So you could do all in one big step, 34.5 times pi, and divide that on both sides. So that would make the pi's cancel, the 34.5 cancel, and the only thing left is the radius squared. So the radius squared, if you type that into the calculator, is about 25. So the radius isn't 25 feet long. Radius squared would be. How do you get rid of the little 2, the little squared? What's the opposite of squaring something? Square rooting something. So you do that, and you get that the radius is equal to about 5 feet. And at the end, there's still just one more thing to do. We're after how long the stick is. So the pole would equal 1 foot to start off with. That's the part that's sticking out of the top of the tank. And then you're going to have to add on a radius, which is 5, and that's still not done. You still have to add on another radius. So the pole would have to be 11 feet long. I think I've seen them use that pole in the gas station before, like to dip in to the tank to measure it. I've actually, I don't think I did. I know that in my life I've seen someone with one of those long poles measuring the gas.